if you do research into what actually causes bugs in programs, it's kind of hard to necessarily pin things down specifically to design. But when I looked at this body of research, and I've looked at it a number of times at this point, I think that's effectively what it's communicating is, a lot of the studies will look at more specific things, but when you break it down and sort of look at it, on like sort of a meta-analysis, I think what it shows is that the biggest source of bugs are really related to design. Programmers jump into a code base and they don't understand what some piece of code does. They think it does one thing, and so they try to use it that way, but it actually does something else. Or they're like, oh, I don't know how to make it do what I want to do. I'm just going to sort of force it, We've all been there. It's like your boss is like, okay, this has to be done in a week. And you're like, well, this code is just not set up for this. Like, it's not made for this. Well, it's got to be done in a week. All right, well, here goes. And, you start piling that on top of each other. Anyways, you can write it in TypeScript. It might compile fine without type errors, but it really doesn't matter. Your program still sucks. So anyways, yeah, there's a lot of research into this. My conclusion, and I think other people would, some other people at least would agree, comes down to design is really the source of the biggest, most fundamental bugs in the program. And yes, there have been studies that have shown that using a static type checker does improve the overall quality of your program. I'm not going to deny that. It's undeniable. But here's the thing. This is with all other things being equal. So if all other things are equal, then yeah, static type checking undeniably improves the overall quality of a program. But there is one very key element to that statement. It's where I said all other things being equal. To explore what that means, we need to take a look at another aspect of programming, the budget. It doesn't matter whether you are programming for yourself, someone else, or a company. There is always an explicit or at least an implicit budget. It might be as simple as I work on this in my spare time to extremely detailed budget documents. Either way, there is a budget. And the most important aspect to a good program, like we've established, is good design, choosing the right abstractions. Good design, though, is costly. It takes time, a lot of time, especially up front. It always pays off, in my opinion, in the long run, but it's very costly up front. And when we look at a well-designed program is one that is easy to extend and maintain in the future. And this means that it is overall cheaper. It costs less overall over the length of the project, but it might have a very steep upfront cost, that initial design cost. So we actually, if you're curious about like some of my thoughts more in depth on design and my experiences, with well-designed projects and how to get there, we definitely have some past episodes on that. So I'm not going to go into it in like a ton of detail here. But sort of the summary is that the best approach I have found revolves around prototyping to some extent. So to create the right abstractions, you have to understand the problem space well. And the most cost-effective way I've found to do this is to create prototypes. It's not the only way. You can learn how to create the best abstractions other ways, but it's the most cost-effective way I've found. But regardless, even if you don't create prototypes, I can basically guarantee you that your first attempt at a program will just not be the best design fit. You're going to learn things, while you're writing it, right? You'll learn like better designs as you program it. And after you finish the first version, you'll have better ideas too. This is always how it works. Like talking with your buddies at work, like, oh yeah, well, now that I see how we're actually doing this or what they actually wanted, we should have done it this way, right? Like that happens. That's how it works. Or even if it's your own project, that's the nature of things. So if you have a limited budget, where does the time to design actually come from? How much of your time or money have you dedicated to getting the abstractions right? If you're putting your time into things like static type definitions, is that taking away time from creating good design? You'll probably be throwing away the first few versions if you are really trying to create good design. So again, what's the point in spending some of your precious time on type definitions if you're just going to throw, this code away or most of it away, or it's going to evolve, right? This really gets to my main point. We have a limited budget, and the best thing we can do with this budget is to create the right abstractions, while also obviously getting the program to meet all of its feature requirements and be well tested. But given the baseline, we have a functioning program that solves the user's needs with a good user experience, blah, blah, blah. The best thing we can do is give it good design, choose the right abstractions. And so the reality is, I don't actually have a problem per se with TypeScript. In fact, I'm really glad it exists. You might be surprised to hear that at this point. But static typing is actually really useful. Once I've nailed down the right design and implemented all the right features, I often go back and add some type definitions, especially to things like API boundaries. Catching bugs or more bugs, up front is certainly something that I want. So I'm glad TypeScript exists, but I never want to do it at the cost of good design. And this is really the problem that I've identified. What I see in practice with TypeScript is that people often use it right up front and often, in my opinion, in place of actually doing design. The thinking seems to be, if I'm using TypeScript and carefully speccing out every interface, then my program will just be high quality or higher quality, But this really, in my experience, my opinion, couldn't be further from the truth. In one sense, yes, you will have less type-related bugs. Yay! Great! That's good, right? But overall, type-related bugs are kind of a minor aspect of a good program. Like I said earlier, you have to, you can have the most perfectly typed TypeScript program that uses all the wrong abstractions and is a nightmare to work with. I've been there. It's often how things go.